Hi, I'm Mary McQuilkin, adjunct faculty with the University of Alaska Fairbanks Center for One Health Research. This lecture is about food systems and associated antimicrobial resistance. Part one starts with how food systems contribute to global warming to put the issue into context, then briefly covers the influence of supply and demand, land use and deforestation, food deserts, and food waste. Part two continues with antimicrobial use in food systems, antimicrobial resistance, and the health consequences of antimicrobial overuse and subsequent antimicrobial resistance. Before diving into the impacts of food systems on the health of populations and ecosystems, I want to first set the stage with the broader context in which these issues exist. Animal agriculture is directly responsible for only 5.8% of global greenhouse gas emissions. But keep in mind that isn't including all the emissions from processing, packaging, transportation, and retail. While food production is a factor in environmental degradation and adverse human health outcomes, it's not the largest driver of these challenges. To review, when greenhouse gases like carbon dioxide, methane, nitrous oxide, and ozone are released into the atmosphere, they absorb and emit radiation within the thermal infrared range. This process, known as the greenhouse effect, is the primary driver of global warming. To put food systems into context from a climate perspective, the causes of climate change can be broken down into the following categories. Generating power produces the largest portion of global emissions from burning fossil fuels to produce electricity and heat. Globally, most electricity is still generated by burning coal, oil, or gas, which generates greenhouse gases, while a third of electricity comes from wind, solar, and other renewable sources, which, as opposed to fossil fuels, emit little or no greenhouse gases. Growing energy demand for heating and cooling, rising air conditioner ownership, increased electricity consumption for lighting, appliances, electronic devices, and most recently, data centers to power artificial intelligence have contributed to a rise in carbon dioxide emissions from buildings in recent years. The manufacturing industry is one of the largest contributors to greenhouse gas emissions worldwide. This includes plastics, which are made from fossil fuels, machines that run on coal, oil, and gas, the construction industry, mining, and other industrial processes. When looking at carbon dioxide specifically, cars and vans produce the greatest portion of emissions, followed by heavy freight vehicles. Taking public transportation instead of driving a personal vehicle reduces carbon dioxide emissions by about 45%. Nearly half of global transportation carbon dioxide emissions in 2022 came from cars and vans. But it's important to put carbon dioxide emissions into context because air travel contributes more when you include non-carbon dioxide emissions and factor in the impact of emitting pollutants at high altitude. Note that this graph was produced by the BBC, so the passenger car data was calculated using the average diesel car. As an example of how much air travel contributes to greenhouse gas emissions, flying from London to New York emits about the same amount of carbon dioxide that a person living in Ghana produces over the course of a whole year. The transportation sector ranked second worldwide for carbon dioxide emissions after the power industry in 2022. Deforestation, together with agriculture and other land use changes, is responsible for about a third of global greenhouse gas emissions. Every year, about 10 million hectares of forest are destroyed. Cutting down forests, which is often done to create farmland or grazing pastures, generates emissions because when trees are cut, they release the carbon they had been storing. Deforestation also reduces the Earth's ability to absorb carbon dioxide, since plants use carbon dioxide along with light and water during photosynthesis to produce oxygen and glucose. Deforestation is also a major driver of biodiversity loss because about 80% of terrestrial species reside in forests. While small-scale farmers are responsible for about a quarter of this deforestation, commercial agriculture is a much more significant problem. Our lifestyles have a profound impact on ecosystem health. Consumption of clothing, electronics, plastics, in addition to food and electricity, all contribute to greenhouse gas emissions. The wealthiest people are disproportionately responsible. Globally, the top 10% of emitters of carbon dioxide, 771 million people, are responsible for about 48% of global emissions. The bottom 50%, 3.8 billion people, are responsible for about 12% of global carbon emissions. The global top 1% contribute 17% of carbon dioxide emissions in a year. Nitrous oxide is 300 times more potent than carbon dioxide, and it also depletes the ozone layer. Nitrous oxide has a much shorter half-life, so reducing its emissions could have a much faster and significant impact on global warming. Agriculture is the largest source of nitrous oxide, mostly from fertilized soil and animal waste. In the US alone, fertilizer use has risen more than 200% over the last 60 years, even though our amount of cropland has remained relatively constant. In this graph comparing the carbon footprint of different protein-rich foods, greenhouse gas emissions are given as global average values based on data from 38,700 farms in 119 countries. Emissions were measured across the full supply chain, from land use change through to the retailer, including on-farm processing, transport, packaging, and retail emissions. The height of the curve represents the amount of production globally with that specific carbon footprint. The white dots mark the median greenhouse gas emissions for each food product. Interestingly, many nut producers are carbon negative, even after accounting for other emissions and transport. This is because recently tree nuts have been expanding into former cropland, which removes carbon dioxide from the air. This graph is based on that same data set of 38,700 farms from 119 countries, but includes more than just protein-based foods. Green represents above-ground changes in biomass from deforestation and below-ground changes in soil carbon. Brown represents methane emissions from cows, methane from rice, emissions from fertilizers, manure, and farm machinery. Orange represents on-farm emissions from crop production and processing of feed for livestock. Blue represents emissions from the process of converting raw agricultural products into final food items. Red represents transport emissions. Yellow represents retail emissions, including refrigeration. And gray represents emissions from producing packaging materials. You can see that beef cattle herds have a very high carbon footprint due to methane produced by the cows directly, land conversion for grazing, and animal feed. In recent decades, quality of life has improved around the world. Life expectancy is rising, poverty is declining, and access to goods for many is increasing. 3 billion people are expected to enter the global middle class by 2050. This socioeconomic transformation has significant implications for food systems. As incomes rise, dietary patterns typically shift towards higher consumption of animal-sourced foods, refined grains, and processed foods. This places production demand on agricultural systems to grow additional animal feed, additional food animals, and the processing, shipping, and other steps along the way to reach the point of sale. This growing demand globally underscores the need to transition to more environmentally sustainable food systems. Global meat production has increased fivefold since the 1960s. Until just recently, there had been a global trend of decreasing cost of meat production. This resulted from increased supply of animal feed, such as soy and corn, which subsequently increased the supply of meat for many countries. Globally, the animal protein market is expected to grow from $23.16 billion in 2025 to over $34 billion by the year 2034. Demand for meat has especially increased in China. In 2024, Asia dominated the animal protein market, with a market share of 43.72%. In the US, beef prices have risen significantly since February 2020, with steaks rising 54% and ground beef rising 51%. Several factors are contributing to this price increase in the US. Many years of drought led many farmers to not be able to irrigate their alfalfa, which would have been used as animal feed in the future. So many American ranchers who were impacted by drought in recent years ended up selling a lot of cattle because they couldn't afford to feed them. In addition to tariffs and rising interest rates, another factor driving up prices in the US is the New World screwworm. It's spread by a parasitic fly that's attracted to and lays eggs on open wounds and mucous membranes. Screwworm was in the US previously, but it was eradicated from the US and Mexico in the early 2000s by releasing sterile male flies that would mate with the females and end the reproductive cycle. The current resurgence started in 2023, and initially in November 2024, then again in 2025, the USDA blocked importation of cattle from Mexico in an effort to protect US cattle from the parasite. One female fly can lay 300 eggs at a time and can lay up to 3,000 eggs during her lifetime. When the eggs hatch, the larvae feed as they burrow into live tissue, like a screw being driven into wood, hence the name. The larvae cause extensive damage to the host's tissues. An infected cow may die in as soon as 10 days. Infection is extremely painful and causes bleeding from non-healing wounds and a sensation of the larvae moving as they burrow through infected tissue. In September 2025, the FDA gave conditional approval for a drug for cattle that can be used for both prevention and treatment. Otherwise, treatment is a tedious process that involves physical removal of the larvae and disinfection of the wound. An impact analysis by the USDA estimated that a screwworm outbreak in Texas, which has 12.5 million cattle, about 14% of cattle in the US, would cost $1.8 billion a year for the Texas economy alone. The uncertainty of potential screwworm outbreaks in the US has further driven up beef prices in an industry already facing challenges. In addition to the economic impacts, if screwworm became endemic in the US again, it would pose a threat to the health of humans and other animals. Screwworm can infect any warm-blooded animal, so the risk is not limited to the beef industry. Food production is an important driver of environmental change and habitat destruction. 1,000 years ago, it's estimated that less than 4% of the world's ice and desert-free land was used for farming. Farms and pastures now occupy about half the planet's habitable land. Croplands alone cover an area roughly equivalent to South America, while pastures for grazing livestock use an area the size of Africa. But not all diets require the same amount of land. It takes around 1.2 acres of agricultural land to feed a person per year on an average global diet, which is around 40% less land than is needed to sustain the typical American diet. Meat and dairy production are particularly resource intensive due to the space and crops required to raise and feed livestock. Only half the world's croplands are used to grow crops that humans consume directly. If we combine global grazing land with the amount of cropland used for animal feed, livestock accounts for 80% of agricultural land use. Meat production is also water intensive. Producing just 1 pound of beef requires over 1,800 gallons of water, which is equivalent to about 90 showers. If the global population adopted the average American diet, existing cropland would need to double. Even within the US, there are disparities in access to nutritious food. About 1 in 7 Americans is currently experiencing food insecurity, meaning they have limited or uncertain access to adequate food. Over 1 in 14 Americans live in areas with little or no access to fresh and affordable food. The USDA definition of a food desert requires that both the area be low income and have low access to nutritious food. Census tracts qualify as food deserts if they meet both low income and low access thresholds. A poverty rate of 20% or greater, or median family income at or below 80% of the statewide or metropolitan area's median family income, and at least 33% of the population lives more than a mile from a supermarket in an urban area or 10 miles in a rural area.
Not surprisingly, almost the entire state of Alaska meets both the low income and low food access criteria to be classified as a food desert. These food deserts exist both in urban and rural communities without ready access to fresh, healthy, and affordable foods, and contribute to the high rates of obesity, hypertension, type 2 diabetes, some cancers, and cardiovascular disease in the US. Many of these communities also have high concentrations of fast food restaurants and convenience stores that sell high calorie, nutrient poor foods, which exacerbates disparities in access to nutritious food when combined with socio-ecological factors such as neighborhoods that aren't walkable and have limited access to transportation. Addressing disparities in access to nutritious food requires not only increasing availability of fresh foods, but also tackling the broader social and economic determinants of health that shape the U.S. food environment. Despite the 35 million Americans who lack access to adequate food, we simultaneously have a problem of food waste. About 40% of the entire U.S. food supply is never eaten, equivalent to about 20 pounds of food per person per month being thrown away. The production of wasted food in the US is equivalent to the greenhouse gas emissions of 37 million cars. While the US is a major offender, food waste is a global problem. Food waste occurs at every stage of the supply chain, from farm production and processing to retail and household consumption. The environmental cost of this inefficiency is profound. About 31% of U.S. cropland and 25% of the nation's fresh water are used to grow food that will ultimately be wasted. Food is the single largest component taking up space in U.S. landfills, making up 22% of municipal solid waste. In an anaerobic environment, food generates methane as it decomposes. Economically, the U.S. loses an estimated $165 billion annually due to discarded food. Here's a few quick practice questions before taking a break. When combining deforestation, crop burning, livestock, and other food production processes, the agricultural sector ranks blank for global greenhouse gas emissions after the blank sector. The agricultural sector ranks second for greenhouse gas emissions after the energy sector. 80% of global deforestation is caused by agricultural expansion, which includes creating pasture for livestock to graze and cropland for farms. Up to what percent of the U.S. food supply is wasted? 40%.
Continue to part 2 of the lecture about antimicrobial use in food systems, antimicrobial resistance, and examples of the health consequences.